Hey, how's it going? My name is Mr. Milanese, and today we're talking about box and whisker plots. Okay, so how do we handle a situation where we're trying to make a box and whisker plot, but there are also outliers? Well, the first step is to put your data in order and set it up like you would any normal box and whisker plot. The question, of course, is what does this data represent? Well, I'm lame, and so I'm using the same example that every math teacher ever uses, and we're gonna pretend like these are test scores, and I'm gonna make a box and whisker plot out of it because that's what math teachers do in their free time. So the first step is put the numbers in order, so we're gonna do that right now. Okay, now that I have the numbers in order, all I'm gonna do is record the 5 important numbers like I would for any box and whisker plot. So we'll start with the minimum, which in this case is a 5. Yeah, this guy made a 5% on the test. Obviously wasn't his day. So the minimum is the smallest number. Maximum, of course, is the biggest number, which is a 96. The median, if you remember, is the middle number in the set of data once they're in order. And now that I've got them in order, I'm literally just gonna count to the middle and see which number is in the middle. So we've got 5 and 96, 68 and 94, here, 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 and then we're in this situation where it looks like it's in between 78 and 80, like they're tied for the middle. So what do we do in that case? Well, we're gonna average these two numbers. You could probably just do that in your head. The average of 78 and 80, the number that's right in the middle is 79. So our median is 79. Now keep in mind that that median, it's really not showing up in our data set, it's in between there. So think of it as like invisible median right in the middle. I say that because when we find quartile 1, remember quartile 1 is the median of the first half of data, not including your median. Okay, so here's what that looks like. If we look at just this part of it, just the first half of data, we are gonna include the 78 because remember, 78's not the median. I know it helped us calculate the median, but it's part of the first half of data. So we're gonna use that and we're gonna count to the middle and that'll be our quartile 1. So it's the middle of the first half of data. So we've got here, here, bingo. This is the middle of our first half of data. So that's gonna be our quartile 1, that's the 76. Same thing on the upper end to find our quartile 3. We're gonna look at the upper half of the data. Remember, not including that 79 because it's not even technically in the data set. So we're gonna count to the middle, and in this case, it is an 88. So that is our quartile 3. And now what we have to do is put these on the number line. Normally what we would do is we would just put dots in each one of these positions and then draw the box and whisker plot. Here's the one problem. This data set has an outlier, and if you're looking at it, you can probably tell, even if you've never heard of this before, what the outlier is. An outlier is just a number that's very different than the rest of your data set. Oftentimes it can really throw off your average, either really high or really low. In this case, wild guess which number is our outlier. Of course, it's the number 5. It's very different than the rest of the data set. Now, how do we handle that when we make a box and whisker plot? Well, it kind of depends on your teacher, but most of the time, the simple way is to show that it exists, but that it's not part of the box and whisker. So a lot of times you can do that with like a little asterisk. So I'm gonna put an asterisk right where the 5 would be, but I'm not gonna draw my box and whisker plot. In other words, I'm not gonna extend the whisker all the way to 5. I'm gonna extend the whisker to the next smallest number. So instead of 5, the next one would be a 68. So that's gonna be the minimum that I'm gonna use on the box and whisker plot. So let's put a dot at 68, which would be right around in here. Remember, it's floating above the line. Our quartile 1, we need a dot right here at 76. We need a dot at the median, which is 79. We need a dot at quartile 3, which is 88. And we need a dot at our maximum, which is 96. Okay, so if you've never made a box and whisker plot, this is gonna look a little weird. We make a box, a rectangle, out of the middle 3 numbers. So it's gonna be like a vertical line here. We're gonna go over and down, and then we're gonna create a vertical line straight through the median. So what we've done so far is we made our box or our rectangle out of Q1 or quartile 1, the median, and the third quartile. Okay, that's the box part of the box and whisker. Then the last part is to extend the whiskers out to the minimum and out to the maximum. Okay, so we've connected these dots. And of course, this shows where 1/4 of the data is in this section, 1/4 of the data is in this section, 1/4 is here, and 1/4 is here. But what we've done is we've shown on our number line that there is information down there, but we're not letting it be part of our box and whisker because it's very different than the rest of our data set, and we call that an outlier. Now, I gotta warn you, that's one way to address an outlier. The other way is to formally calculate if something's an outlier. Now, we just glanced at this and said, well, 5 is very different than the rest, so it's probably an outlier. So if that's all your teacher wants you to do is just say outliers are numbers that are very different, then this is all you've got to do, and you can just ignore the rest of this video. If, however, you're asked to calculate outliers, like using the official way, then stay tuned for the rest of the video. Okay, so if you're still with me, you're trying to find out how to formally calculate if a number is considered an outlier. And it's a pretty straightforward way that we're gonna do this. It might look a little complicated right at first. If you remember from the first part of the video, we said that we had determined, according to just our quick test, that 5 is very different than the rest of the data set, and therefore it is an outlier. But how can we be sure? How can we officially calculate whether or not something is an outlier? Well, it's a little tricky at first. We're gonna look for numbers that are either less than the first quartile number minus 1.5 times the IQR, or numbers greater than the third quartile number plus 1.5 times the IQR. And that's enough to make you turn this video off right away. Stick with me, it's not that bad. First of all, what is IQR? Well, it stands for the interquartile range. It's just a fancy way of saying, what is the difference between my third quartile and my first quartile? So that part's easy, it's just a subtraction problem. So let's do that first. My third quartile in this example was 88, and my first quartile was 76. So I'm just gonna subtract those numbers. So my IQR is 88 subtract 76. 88 subtract 76 is 12. So for this data set, my IQR, or my interquartile range, is 12, okay? Now what we're gonna do is we're gonna substitute that value into the rest of this sort of inequality to see if we have any outliers. Okay, well, what is our quartile 1? From our data set, we know that it's 76, and we wanna take 1.5 times the IQR, which we already found to be 12. Okay, so let's do a little bit of mental math here. 1.5 times 12 is 18. So that means I'm really looking for numbers that are less than 76 minus 18, okay? All right, so let's try that again. So the last step here is 76 minus 18, which is gonna be 58. In other words, I'm looking for numbers that are less than 58. Do I have any numbers in that data set that's less than 58? And of course the answer is yes. 5 is much less than 58, therefore it officially should be considered an outlier. So we would, using the lower end, we would say yes, we do have a lower outlier or an outlier on the lower portion of our data. For thoroughness, let's just look at the top half of our data. An outlier could also be a number that's greater, a lot different than the rest of your data set on the high end. So let's just do that same thing. Let's substitute in our values. Our third quartile is 88 plus 1.5 times our interquartile range, which remember is 12. So we're checking for an outlier on the upper end of our data. So similarly, so we're looking for numbers that are greater than 88 plus 1.5 times 12, which is 18. Okay, so again, some quick mental math. 88 plus 18 is 106. So I have to ask myself, are there any numbers greater than 106? And there aren't. So that means that we do not have an outlier on the upper end of our data, but we do have an outlier on the lower end of our data. And again, depending on if your teacher is asking you to just say an outlier is very different, then you don't need to mess with this. But if they want you to calculate an outlier, this is how we handle a box and whisker plot with outliers.